Cool. So homework 6 is up, and we will go over it today, but it will be a little bit tricky. I'll just hint you. So work on it as soon as possible. Now that you likely all have access to this room. Good. Okay. Um, there's supposed to class after this, but somehow I don't think they meet every week. So if you want, you can just stick around or, come earlier. Cool. We can look into some of the thing we talked about last no, on Monday. So we basically talk about additive, no, ADSR, envelope additive synthesis, and AM synthesis, basically. So ADSR, I guess the biggest part of it is to think about, this function thing. So that's one of the key thing about ADSR is to work with this function thing. So it's called basically just function. So n function, then you will get the thing. One thing tricky about that is that you have to set the range of it. So there's a typo here. But anyway, once you set the range, now this set domain 1000. So in this case, you can use $I1. That will be the first integer you get. So in this case, there's just one integer coming in. So that will be set domain 1000. So that effectively turn that set domain things into set domain 1000. So this was set this things to 0 to 1000. And that effectively turned it into 0 to 1 second. So this sound will be 1 second long in this ADSR thing. But basically that's what we want. Cool. And anyway, we can get the sound. We have the sound? No, we don't have the sound. Oh, because I didn't. Cool. So you can hear that thing. So one thing about it is like you can just grab around these things, so that you can create a much longer attack that just raise up slowly. And if you like to add more, you can just click on it and you can press Shift to get rid of unwanted dots. Usually in Macs, I would say just try Control Shift Alt or Command Option and what's the other one? Control Shift whatever. Just try and one of them will be the one that you're looking for. So in this case, Shift. But there's other stuff. Anyway, so you can play with this, but essentially the second outlet of this is what we want. It will generate this thing. So this thing is basically stay at 1, wait for 1 second and set a, go to 1 after 407 millisecond and go to 0.3, this case, after additional 55 millisecond and, go to 0.34. I think there's additional, let me try again. Okay, this is the case. So go to 0.99 after 138. So this is 138. Go to 0.3 for another 325 millisecond. Now go to 0.34 this case, after 340, and then finally drop to 195 at the end. And at the end will be, totally sum up to a second. So that's essentially what you need. And you can turn this into a real signal that you can times it. So this line will actually turn these numbers into these things. So this is essentially what you want. So what you want is basically a line that look in this shape, basically. So now once you have this, you can actually just times it with the cycle that you have. So this sound will just go from 0 amplitude to this and drop and then go to the bottom. So this is technically not ADSR actually, because ADSR has to work with the node off thing. So this is a sort of like one-shot envelope. So this is not technically ADSR. So keep that in mind. For ADSR, we are thinking about sort of more relevant to the one that we are doing in homework 5, where key when you press the key and when you lift the key. The sustain and decay only happen for that. Cool. Anyway, we can combine all those, you can have note in, but you can also have the key to do it. Cool. So that's IDSR. And we also look at, additive synth. But basically, this is the very basic type of synthesizer where what you want is basically just grabbing all different components of that. So say we have a C. You're basically just combining different sort of like frequency from F0 to 2F0, 3F0, and that essentially just changes the timbre of that. So if you lower the frequency, but add more higher frequency, ones that are brighter, so all sort of like different kind of sounds. So this is essentially, what timbre means, right? Timbre is just a combination of, all these different harmonics. Of course, it's a bit more complex than that, but, the idea is that why we are doing, FFT, STFT is that trying to decompose the sound into frequency components, but now we are trying to do it the opposite way. Can we use sinusoid function of different frequency to together compose a sound? So this is additive synth. But additive synth is not that powerful in terms of, it's not sounding the best, and it's oftentimes very tricky to see what you're looking for. So today we will, well, actually before that, there's also the AM synth thing, but basically it's just doing modulation on the amplitude rather than the frequency. So today we will look into the frequency modulation thing, and that's essentially the good old, Yamaha synthesizer, or the FM, good old FM synth is about. Cool. I guess we could just skip this. Cool. FM synths. So I think I've shown you a little bit about that last Monday. But basically, this is the idea. So initially, it's just like, well, can we have a cycle that's just doing this sine wave? And this is like for one. So this is basically trying to change that output basically. So let me see how I can show it. Anyway, what you see and hear is that this the sound that you hear go from 0 to 440 frequency and going back and forth basically. So now you're hearing this changing frequency over time. And FM synth is basically just playing with this idea about in a much more complex way. So the idea here is that, well, again, similar to amplitude modulation, we will have a carrier, which is just a pure sound wave. We can actually listen to this sound wave. Anyway, let's just do it this way. Let's try. Let's see if we modulator. Let's do 0.2, 0.5. So the idea here, you can see from the modulation depth. So what's going on here is that you are adding additional frequency to the core frequency. So this is your core frequency, it's 440, and you can see that you are adding something here. So now you are, so you have like 440, that's your frequency, 440. But now you are adding another cycle, which this cycle is like a frequency of 7. and there's some modulation depths. But think about it as something like this. You are adding some fluctuation between center around that frequency that you have. So that's the idea of that. So let's see how I can do this modulation depth. To turn up a little bit. You can see that we actually turn the sounds into a much interesting way. So does that remind you of some of the early day synth sound? But basically what's going on here is that now we are adding some frequency fluctuation on top of that carrier frequency. So previously what we are showing here is that the things just go from 0 to 440 and going back and forth. But now frequency modulation is that we are actually, if we turn it very slowly, what you see here is that, well, I'm moving around 440 with some 80 modulation depths. So if it's 80 modulation depth, where's the what it happens is that you will go from, this is 440, you start from 440, and then you will go up until 440 plus 80, 520, and then you go down to 440 minus 80, 360, and you go back to 440. And so this is basically just like, the whole FM is about, where you have a specific center frequency. Now you fluctuate around that frequency. And now you can control two things. One thing is about modulation depth. Modulation depth, meaning that how much you are deviating from your current frequency. So this height. But the other thing is like how frequent you change the things. So this is the mod frequency. This is the mod depth. So those are basically the two things that you can do. So if you listen to this, listen to it, it's basically something like this, right? It's just like moving back and forth. And frequency up and down. And now interesting things happen when you increase the frequency. Actually just create a very complex texture of the sounds that you have. And you have this modulation depth that you can also play with. Without the modulation, it just doesn't change the sound. If you increase it, then it will be moving around very well. Usually to some fraction of this, you will hear that complex sound without hearing that wobbling effect. So this is essentially, FM. For now, you don't you won't see why this will lead to anything reasonable. But actually, just with these, you can actually, and plus ADSR, you can actually create a lot of sounds that you know about early time FM synthesizer. So one thing we can do here is that combine what we have previously so that now we are doing it on top of the frequency that we have. So this is the same thing we know. We can also use the keyboard as note-in. This would be much easier, I guess. Let me add a note in here. Well, let's move it around. So now, given that we have the keyboard, then I can just use the keyboard directly. So I send the keyboard pitch to this empty. So these are, these are homework file, basically using your keyboard ASDF to do it. But this is like, now we have the keyboard. It's not showing anything. Oh, these are the thing. Let's do it. Oh. So what's going on here is essentially whatever we want. So now instead of like setting, 3 absolute number that you have in this case 440, this is the carrier frequency, and you have the modulator frequency, how frequent you move around that. And this is like how deep you move that frequency is about. Now you turn it into something else where everything will depends on your input. So say, you still have 440, say 60, 69, you get 440. And now the idea is that to determine the modulator frequency, now you define this harmonicity number that's basically determine that output for you. So you can see that this is output. This output, we can show it here. So this is the modulator frequency. So let me click it again. So now if I set it to 0.5, meaning that our modulator frequency will always be half the input frequency. So now, it becomes sort of like input frequency dependence rather than in this case, is everything is absolute. So that's the beauty of FN Synth. Now you can sort of like just play with it and try with different sounds. So now rather than the actual specific modulation frequency and the original frequency, now it's like original frequency determined by the MIDI note number and its corresponding frequency. Now the modulator frequency is a fraction of that input frequency. So now you can play with different sounds basically. So this like 0.5, we can also do 0.4. This is the same idea. But basically, a lot of these is just like finding interesting sound between these all different kinds of harmonicity and modulation depth. So you can also play with these. Okay, now still it's not so clear what we are aiming to, but now let's make it even more complicated. So now we talk about this, sort of modulation thing. So what we can do here, let me try to set it up. If this is 0.5, cool. So let's dig into what's going on here. So now things is a little bit even more complicated. So compared to this, what we are seeing is that this modulation depth is predetermined. But now, what if we make this modulation depth into something that you can also change? So the idea here is that, well, now we have that modulation frequency. We turn this modulation frequency and change it over time. So the idea would be basically adding one more modulation on top of the output that you have. I don't know if we can have a good idea of that, but you can sort of see it here. Let me do 0, then nothing will happen likely. Oh, something's still happening. And now you have 0.5, 0.2. Kind of see some interesting sound coming out. Anyway, that's frequency modulation. So this thing is actually quite complicated. So what happens here is that we can actually look into the message and try to see what this is. So again, when I click A, you see this number. Let's do, okay, let's do 69, 0.5. Okay, in this case, so we have like 440. That's our carrier frequency. We have this 440 as our sort of, think about it like an anchor of our frequency. This is our base frequency. And now we times 0.5. This is the harmonicity we talk about. So now that output's 220. So now you are trying to add something on top of this. And so initially what you want to do is something like this. So you basically have a frequency modulation on top of this frequency. So this frequency will sort of like go around, like in this case, where it just move around that thing. When you have frequency that's smaller, say 0.01, that's too small. 0.01. So you will see that it's basically changing the frequency and having it move around. But now if something this is much higher, then there's no way you can see it. Think about it, it's like jumping so frequently that you couldn't tell. But in this case, now you are adding additional modulation that will go from 0 to 1 and go back to 0 on top of this synthesizer that you have. So initially, what happened here is that initially at this point, what happened is that this will be 0, and you send a 0 here. So 0 times 220 becomes 0, and so the things will be 0. We can see it here. Let's say, I don't really know how I can show that number. I think there's a way. Let me see if this is actually helpful. We can actually show these numbers here. Let's see if we can see it. So look at these numbers. So when I press it, it go from 0 to something positive, almost reach 130, and then go back to 0. So that's what happened in this case. Is that this sound basically do that frequency modulation and then turn it back. So the difference between what's happening here is that you always have that frequency modulation. But now this thing is that frequency range expand and then compress again. So what you see here is that, well, there's no frequency modulation. You set at 440. But now if you click on one of the I have to do it at the top. So if I do it basically stop from 440 and then do the frequency modulation and then turn it back. So, or I guess hopefully you get the idea. So at this point, no frequency modulation because everything will be 0, so nothing happened. But at the peak, there will be this 220 frequency modulation. So now, that actually brings us to, the full idea of frequency modulation. So the idea of frequency modulation is that just to play with this thing, basically. And then you can create so many different sounds. Well, it's making that sound. I think 0.9 would give us something interesting. Let's listen to it. And you can try to. So this thing is sort of like act like a thing because it will turn back to the original frequency component that you have. I guess what we can do is now try to do something on this. And in the whole homework 6, then we will combine everything we've seen here. So this is basically what we have as a frequency modulation. So FN Synth is basically thinking about doing this plus ADSR altogether. I can show you how they look like at the end. So let me play something. Let me see. So in this case, now I'm also adding like this ADSR envelope that you see all the way to modulate the last the audio that you generate, and then it goes to the speaker directly. So now you have this fundamental frequency. You have the frequency modulation, which whose amplitude is set by this line. So that frequency modulation will change over time, but at the same time, the final signal that you get will be modulated again by that envelope. So the idea of FN scenes is that you can just basically just play around with these different parameter. Realize some of these sounds in some of the early synthesizer. A lot of like FM synthesizer are just using this. You can also play with this number. And these are the ADSR. So ADSR will sort of change the behavior of the like the attack. I think that's the most obvious one. Cool. What should we do now? I guess let's start it from something simple. Let's try to rebuild this. Shall we? You can copy paste all of these easily, but I guess let's first get this done. You can also just use Node-in without all these, but these will allow you to do your keyboard. So that's everything we just talked about, how the conceptual idea how these things work. But once you start to implement it, just like homework 5, you will see there's a lot of details that's not so obvious. So let's try to do this, and then we will later try to add these things all together to build the final FNCs. Cool. So if you want to see how it actually work in real time, you can actually add these things here.
So that's it, switching between the frequencies?
So this one is actually real time showing what this thing is doing. So basically it's just like positive 142 to negative 142, just switching around that.
Okay. So you take in the note and you're converting it to a frequency, then that frequency is going into a number. Like what is multiplying the harmosity?
So this thing basically determine how you wanna change this frequency. What's the frequency you are changing this frequency? But basically now the idea is that, well, this is 440. Now you can set something there, but it's not dependent. It doesn't depends on the input frequency. So now, because you are using MIDI input, right? So you will have potentially different, no, somehow it's not working. Yeah, somehow it's not working. Anyway, but this will be the frequency. Now you want that frequency depends on some fraction of that. So now you can set this as, 1.
Oh.
Then it will be changing that to frequently, and it just becomes something like this. It doesn't sound interesting, but if you do something like 0.5, 0.9, you see that shape.
For my understanding, to make sure I get it right, the driving frequency from your keyboard is now a fraction of that is the how do you even say
Harmonicity, I think. I don't know exactly.
The H word. But from the key, the harmosity is a fraction of that frequency that then determines how
frequent you change that.
You change it.
Exactly.
So a fraction of the frequency determines the frequency with which we change.
Exactly. Yeah, exactly.
And then the modulation depth is the factor by which we're changing it.
Like how much?
How much, right? That's
how
why
much?
there's a multiply, and it's a number.
Yeah. So this thing is like always cycle is like always 0 to 1, but frequency of this thing now the amplitude of that is 142.
Yeah.
So it go from you can see it here. So this thing is actually you can get here from this number thing. You have integer, you have float, but the third one is actually a signal. So you will see this signal thing, and you can actually grab something to show that signal in real time. So you can see that this basically go from negative 142 to 142 and back and forth, basically. And this is still a step away from this, where we will also change that things also something will change over time. So that's first, right? This. So one thing about this is that this happened to, modulate the frequency modulation, modulate the frequency modulation. This modulate the whole sounds that you get, like the final envelope. So together you can actually just create a bunch of sounds here, like you play with it. But that's essentially what, FN Synth is about. And if you open out some of the example code, it's basically there will be several preset that's already preset. You can also do it in homework 6.
How do you get the visual of the ADSR? Like
Visual
an ADSR, but it just
function.
function.
Yeah.
That. Yeah. And then you put the ADSR into it.
No, you don't need that ADSR thing. That's an ADSR thing is another thing.
Oh.
You can actually also use that, just that tape number. Yeah.
So wait, you just put a function and then you send the audio in?
You want to get that line thing.
Yeah, to draw the ADSR.
Yeah. So the things will output something like this. When I click it, you will see what it generates. This is basically what that.
Yeah, the 4 points.
Yeah. And you want to turn that into the real ADSR, then you have to do the line till that thing. Yeah.
But what goes into the function?
What goes into the function? Just a bang. You just need a bang to trigger it. And this set domain thing is actually set in that so that it's but it defaults to 1 second, I believe. So it doesn't have anything to do with it. So this will set the X range. So even if you have this, you don't necessarily know how long this is. So you can actually set it to 2 seconds, 3 seconds, 4 seconds. So that's just setting how large this X is, the X range, basically.
What you type in bang to get a bang, or you this?
So you just do the button. So this is a button, B.
Oh, I see.
And so everything you can trigger the button. So now everything here is controlled by key. But even if you have like a node in, say if you want to do node in, then you can still use node in to trigger this button. So whenever there's something coming out, you can turn it into a bang message by just passing this through a button.
Okay.
Yeah. So think about it more like a trigger. Yeah. Cool. I guess while you're working on it, we could move on and see how tricky the polyphony things work. And that will be part of homework 6. Cool. So you can also check out this another example code where they have some of the preset of those sounds, and you can hear that. Well, somehow I trigger processing. Cool. Luminosity 0.5, this 1,000.
Oh, I see. So you had the function is equal to the volume of the signal.
Which one are you talking about? This?
The right side, the down.
This is the real ADSR.
Right.
This is the envelope for your modulation frequency.
Okay, got you. And then to have the function that I drew change the volume, I can pipe the line output, like once you put it into the line tilde, you can have it go to is that a multiplier?
Which one?
The thing that the line.
This one? Yeah. This is a multiplier tilde. So this is a signal multiplier.
Cool. And also it's taking the main frequency and it's why would you multiply the frequency by the line?
This is not frequency. This is the final output. This is the FM synthesizer. So this one is like you can double click on this. This is the FM synthesizer we just looked into.
Yeah.
So it takes three inputs: frequency, harmonicity, and modulation index, which is basically how modulated that things. So this is the fundamental frequency. You want to plot it with some signal. This signal is controlled by some fraction of that and
Yeah.
determine the cycle. So this is a sine wave that go through that, and this sine wave is further modulated by some modulation index.
Right.
So everything of these will turn it into some frequency that's changing, and it will turn into a cycle. So now it becomes a signal. It's no longer frequency. So now this is the real signal coming out here, but now this signal will decay over time. So this is the real ADSR. That's how complex it is. So, you can play with this. Basically FN synth is just like playing with all these kind of different things. So you can hear this sound. Another case where, carrier frequency, we could set it to 440 to get it easier. Okay, that it default to 130 anyway. We can hear some of the different cases. And the second one, now harmonicity become 1, a slightly different modulation index. The third one, now harmonicity becomes 0.7 and yet another modulation index. Now we have a much, shorter attack. And, yet another one. Now you have a state here for. So that's essentially what you want to do in homework 6, that you would figure out something. So these are very clean because the harmonicity is just pure number, integer. So it sounds very clean. But whenever you have like a fraction harmonicity, it will have a more complex sound. They're like, that's the idea. So you can also see that this duration actually also changed. So in homework 6, that's basically what we're looking to. Try to combine the two ideas. We will talk about polyphony. I would hint you a little bit, but polyphony is another thing. So, previously, from the questions, previously we are doing that MIDI note on, note off thing, note out basically. So what happened with that note out is that once you send some MIDI information into that note out thing, now nothing is about max anymore. Microsoft or whatever, Mac, whatever synthesizer that you have will handle how many voices and all the polyphony things going on. So you can send so many different information into this note out things, and it will handle those individually. But one thing you will notice is that this doesn't work for polyphony anymore, because everything at the end will send to this competing signal. And there's this one signal here. There's no way you can do this. So if you want to think about how you make polyphony, the idea would be, well, you have the things. Once you press some button, you will trigger the things and then play it. Now, if you press the second button, there will be another whole lot of these things, copy paste, that will handle the second note and for the third note. So that's basically why polyphony for these in Max is a little bit tricky, especially when you have the sound. So I can give you the peek into how that works, but we will work on it next Monday. Polyphony is, again, as I said, very tricky to get it right. One thing before that is that we can actually use this ADSR thing so that it's much easier to work on it. Let me try to demo it. It's not doing anything. What's going on? It's not detecting my MIDI. Anyway,
Keyboard. Keyboard.
this thing, K slider,
Case.
or at the top somewhere here, you can find it. Like the dial button here, everything is about slider. Yeah. Not that one actually. This one. You can find it in here. This one. Um, something weird is happening here. Oh, okay. So this thing is basically the real ADSR. So the thing you just saw that we are constantly using is not technically an SDR. So the thing that you saw, something like this, and even though you feel like it's actually doing ADSR, it's actually not doing ADSR. It's just an envelope that always stop at 1 second. So the real ADSR is that, well, you will only do the things, and then it will be dot 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 until at some point you get the note of, then you will start decay. So you don't really know how long the things will take. So you can actually set ADSR with real numbers to do it. So 10 will be the time you reach the top. Again, that's how ADSR is defined. Attack is the time you reach the top. So from 0 to 1. And then the second number, 100, would be the time you go from this to the sustain level. So this will be D. And S would be this number. So this will be S. So in this case, this S is 0.5. So a more accurate plot of this thing is actually very quickly go to 1 in 10 millisecond. And then you stay for 100 and you reach half of the value. So 0.5 after 100. So this is essentially this ADSR is doing. And then the 500 thing will be, well, we just keep waiting until you get the trigger, and then you will spend 500 millisecond to drop to 0. So you can actually just use this ADSR to do this thing. One thing you will notice is at the right-hand side, you get this velocity thing. So velocity will be 127 or 0, and you divide it by 127. So what you get is actually, we can take a look on these and see what you get. So when I click one of the key, I click it, and then when I lift it, it will become 0. So anything other than that is like 0.29 and it becomes 0. So this ADSR thing is a sort of like a clever thing that when you have something that's non-zero, it will give you that ADSR at that amplitude. And then once it's 0, it will just close it. So you can actually use the things to trigger that ADSR thing.
Is that a divide by 127?
Yeah.
You just hit slash and then 127?
Yeah. And point. This is a float.
Oh.
Yeah. So one thing about the things is that you have to change it into polyphonic here. Otherwise, when you click it, it won't do it. Somehow my MIDI keyboard is not working. Oh, I think it's the, I don't think, I couldn't find it. Anyway. So if you want to play with the keyboard here, you can actually set up the polyphonic. Well, let me click this. And if I do polyphonic,
What's the word for the two graphs? Like, how do I get those graphs?
these things, this one is scope, tilde. So you get the temporal view. This one is spec scope, spectrogram, spectral scope. So spectrogram kind of.
Thank you.
Yeah. Cool. So if you want to change the behavior of this thing, it by default is like monophonic. So when you click on it, it will be, just be polyphonic. But now you can do polyphonic actually. So now you can actually click 3 notes until you turn it off. But in this case, it's not doing polyphonic. Anyway, I will show you how polyphony work here. Let's get rid of this line so that it won't have sound. Cool. So polyphony work at like this. Very tricky. So there's something going on, a lot going on. So one thing that I just talked about is like polyphony is sort of like launching a bunch of this FN synthesizer parallelly, and you want to keep track of which one is on or off. So think about when you play a chord like C, E, G, and so once you press C, you want to launch one of these and then start in synthesizing the C. And then when you press E and you want to launch again this thing, but with another note, and G another note, until like that notes you lift it up. So, or in this case, it reaches zero. So how do you determine when to close that note and when to open that? You want to know when you want to open that when you hit the note, right? Then now, the idea of the whole polyphony in Max is about how do you track when to release that thing. So that's essentially what's going on here. And that's what this poly thing is doing. So this poly is basically, well, now you have so many different notes. What you want to do is that it will assign a voice to each of your input noise. We can actually just see how that go. Here, let me show what you have. So say we have do, mi, so, and you see that this is like 1, 2, 3. So you have the first noise for C, the second note for E, the third one for G. So this thing is automatically assigned a voice. And 10 meaning that there are only 10 notes, 10 voices that you can support. So say if you do more than that, until you reach some number that just go back to 1. So it will close the first one that it launched. So the things, think about it this way is that, well, now you have max. So this is your max patch. Now you are launching this poly tilde thing. It's actually launching 10 of these, potentially 10 of these. So whenever you have the first one, if you have like voice 1, you start a note and you assign it as a noise 1, then it will start this poly my sound things. Then it would start with something like this, and then it will generate like a separate patch to generate your sound. So this will be voice 1. And now if you click on another noise, let me just restart everything here, I guess. Let me just turn these off. Oops. Okay, so say let's start with one of these. Let's turn it back to 1. Okay, 2. So first we started with like voice 2. So this voice 2 will open out of my sound. And because we click it, say this is voice 9, we click it and it will start playing this sound until this sound is released. So now if you click another one, then it will trigger voice 3. So think about there are like 10 parallel sound engines at the same time. And each time you trigger one of those. So the tricky part of that is that you actually want to release some of those things when it's done. So this is happening here, this poly telling these model to sort of release that. But the core idea is just as simple as that, is that, well, you're basically launching 10 of these FN synthesizer at the same time. So you will have 10 of these synthesizer. Each of these is like an FM synth defined by this my sound thing. And there are 10 of them. And whenever you have a new note, you want to know what that voice is. And then once you have that voice, things here, I will talk about it next week. It's basically just changing these things and also to take care about the ordering, which is a little bit tricky, but oftentimes you just copy paste. But basically, you want to know what the voice is. And once you know the voice, you have the pitch, then you send it to this poly things. It will send that pitch to the specific voice that you have. And in this case, there will be 10 of them. We could give it a listen. So, now in this case, we can actually do, I'm not sure why my keyboard is not working. I guess there's something mystical that I didn't press. But anyway, this is also nice. So you can actually do multiple notes at the same time, and you can see that the voice change over time, and you can close some of them without, interrupting with others. But the idea is that you are launching 10 of those synthesizers at the same time. Each of them is monophonic. And that's why, in some of the keyboard, they will say that this is like a synthesizer, usually up to 10. It's like a minimal because 10 fingers. But some of them will be 128 things. I'm not sure what for. But if you are doing some MIDI controlling, then or you want to do, like a glissando, then it makes sense. Cool. We will dig into details of this. But now we are getting into the tricky part of Max. But at least now we are generating sounds, and it's a bit trickier than MIDI, as we see how MIDI is easier to take care of the polyphony. Cool. Any questions? Oh, good. Do you like Max so far? You like it? Okay, cool. Yeah, and isn't it like Touch Designer or is kind of different? Different. Okay, yeah.
Very different.
Okay, interesting. I think, yeah, if you have used like LabVIEW, I think it's most very like LabVIEW, which is more scientific-ish.